In this video lesson we're going to look at the topic of further integration and specifically look at the further integration of brackets, and that would be functions of the form f of ax plus b. Now we have previously learned how to differentiate functions of this form, and remember the integration is the inverse of differentiation. So the fact that we've learned how to differentiate these, we can work backwards in a sense to be able to integrate them. So we'll look at the derivative first. So we've got d by dx of ax plus b all raised to the power n plus 1, and that derivative gives us n plus 1 multiplied by ax plus b raised to the power n multiplied by a, which was the derivative of ax plus b. So that was the chain rule, and we can just simplify that. So that's a multiplied by n plus 1 multiplied by ax plus b raised to the power n. So inversely then, if we have the integral of ax plus b raised to the power n with respect to x, that will give us ax plus b all raised to the power n plus 1 all over a multiplied by n plus 1. And we have to add on our constant of integration here because we have an indefinite integral. And you can see here for this integral, n can't be equal to -1 and a can't be equal to 0 because we can't have that denominator being equal to 0 there. So let's have a look at some examples then. For the first one, we want to find the integral of 5x plus 2 all squared with respect to x. So we need to add 1 onto the power, remember, so that will give us 5x plus 2 all cubed, and then dividing by that power, so dividing by 3, but we also have to divide by the coefficient of our x term here, which is 5. And we have an indefinite integral, so we need our constant of integration also. And then simplifying that, we get 5x plus 2 all cubed all over 15 plus our constant of integration, which is our final answer. So just now it would be a good time to pause the video and copy example 1 down in your notes before coming back for example 2. Okay, welcome back folks. So example 2, we want to find the integral of 1 over the cubed root of 5x plus 2 with respect to x. So we can see here that we've got an expression that we want to integrate that currently isn't ready to be integrated. We still have a radical sign here, so we need to express that with a fractional power, and it will also be negative as well. That's the power will be negative. So that is the same as the integral of 5x plus 2 all raised to the power -1/3. And we're integrating that with respect to x. So adding 1 to our power will give us 5x plus 2 all raised to the power 2/3, and we need to divide by that power. So we're dividing by 2/3, and we're adding our constant of integration because we've got an indefinite integral. Now we also need to look at the coefficient of our x term here, which is 5, and we also need to divide by 5 here. Now, remember we are dividing by 2/3 here, so remember dividing by 2/3 is the same as multiplying by 3/2, the reciprocal. So if we multiply by 3/2, the 3 is on the numerator, the 2 is on the denominator alongside the 5, so 2 times 5 gives us the 10 there, which is where that's coming from. So we've got 3 multiplied by 5x plus 2 raised to the power 2/3 all over 10 plus c. And our fractional power, we can express that using a radical sign, so it's 3 multiplied by the cubed root of 5x plus 2 all squared all over 10 plus c, which is our final answer. So just now it would be a good time to copy this down in your notes, and pause the video before the screen goes blank, and then complete the assigned exercise for today.